Hi, I'm Patrick Perry. I'd like to show you Hyperloop any location. I'd like to show you. Okay, this is called a Hyperloop. Hyperloop, you know how fast you're going is about 760 miles per hour. Let's see. Let me read the. Let me see the read right here. It's called read out loud. Now, now, now I click about read. Now you gotta listen this.
A hyperloop is a proposed mode of passenger and freight transportation, first used to describe an open-source VAC train design released by a joint team from Tesla and SpaceX. One hyperloop is a sealed tube or system of tubes through which a pod may travel free of air resistance or friction, conveying people or objects at high speed while being very efficient, thereby drastically reducing travel times over medium-range distances too. Elon Musk's version of the concept, first publicly mentioned in 2012, incorporates reduced pressure tubes in which pressurized capsules ride on air bearings driven by linear induction motors and axial compressors. The Hyperloop Alpha concept was first published in August 2013, proposing and examining a route running from the Los Angeles region to the San Francisco Bay Area, roughly following the Interstate 5 corridor. The Hyperloop Genesis paper conceived of a Hyperloop system that would propel passengers along the 350-mile, 560 kilometers, route at a speed of 760 miles per hour, 1,200 kilometers per hour, allowing for a travel time of 35 minutes, which is considerably faster than current rail or air travel times. Preliminary cost estimates for this LASF suggested route were included in the white paper: $6 billion for a passenger-only version, and $7.5 billion for a somewhat larger diameter version transporting passengers and vehicles. Although transportation analysts had doubts that the system could be constructed on that budget, some analysts claimed that the Hyperloop would be several $1 billion over budget, taking into consideration construction, development, and operation costs. 5, 6, 7. The Hyperloop concept has been explicitly open-sourced by Musk and SpaceX, and others have been encouraged to take the ideas and further develop them. To that end, a few companies have been formed, and several interdisciplinary student-led teams are working to advance the technology. 8. SpaceX built an approximately 1 mile long, 1.6 kilometers, subscale track for its pod design competition at its headquarters in Hawthorne, California. 9. Contents. 1. History. 2. Theory and operation. 2.1 Initial design concept. 2.2 Proposed routes. 2.3 Open source design evolution. 2.4 Mars. 3 Hyperloop companies. 3.1 Virgin Hyperloop 1. 3.2 Hyperloop transportation technologies. 3.3 Transpod. 3.4 DGW Hyperloop. 3.5 Arrivo. 3.6 Heart Global Mobility. 3.7 Hyperchariot. 3.8 Zeleros. 3.9 Hyperpoland. 4 Hyperloop pod competition. 5 Criticism and human factor considerations. 6 Political and economic considerations. 7 Related projects. 7.1 Historical. 7.2 Current. 8 See also. 9 References. 10 External links. History edit. The general idea of trains or other transportation traveling through evacuated tubes dates back more than a century, although the atmospheric railway was never a commercial success. Musk first mentioned that he was thinking about a concept for a fifth mode of transport, calling it the Hyperloop, in July 2012 at a Pando Daily event in Santa Monica, California. This hypothetical high-speed mode of transportation would have the following characteristics: immunity to weather, collision-free, twice the speed of a plane, low power consumption, and energy storage for 24-hour operations. 10. The name Hyperloop was chosen because it would go in a loop. Musk envisions the more advanced versions will be able to go at hypersonic speed. 11. In May 2013, Musk likened the Hyperloop to a cross between a Concorde and a railgun and an air hockey table. 12. From late 2012 until August 2013, a group of engineers from both Tesla and SpaceX worked on the conceptual modeling of Hyperloop. 13. An early system design was published in the Tesla and SpaceX blogs. 114, which describes one potential design, function, pathway, and cost of a Hyperloop system. 1. According to the alpha design, pods would accelerate to cruising speed gradually using a linear electric motor and glide above their track on air bearings through tubes above ground on columns or below ground in tunnels to avoid the dangers of grade crossings. An ideal Hyperloop system will be more energy efficient. 15. 16. Quiet and autonomous than existing modes of mass transit. Musk has also invited feedback to see if the people can find ways to improve it. The Hyperloop Alpha was released as an open source design. 17. The word mark Hyperloop, applicable to high-speed transportation of goods in tubes, was issued to SpaceX on April 4, 2017. 18. 19. In June 2015, SpaceX announced that it would build a 1-mile-long, 1.6 kilometers, test track to be located next to SpaceX's Hawthorne facility. The track would be used to test pod designs supplied by third parties in the competition 2021. By November 2015, with several commercial companies and dozens of student teams pursuing the development of Hyperloop technologies, the Wall Street Journal asserted that the Hyperloop movement, as some of its unaffiliated members refer to themselves, is officially bigger than the man who started it. 22. The MIT Hyperloop team developed the first Hyperloop pod prototype, which they unveiled at the MIT Museum on May 13, 2016. Their design uses electrodynamic suspension for levitating and eddy current braking. 23. On January 29, 2017, approximately 1 year after Phase 1 of the Hyperloop pod competition. 24. The MIT Hyperloop pod demonstrated the first ever low-pressure Hyperloop run in the world. 25. Within this first competition, the Delft University team from the Netherlands achieved the highest overall competition score, winning the prize for Best Overall Design. 26. 27. The award for the fastest pod was won by the team WAR Hyperloop from the Technical University of Munich, TUM, Germany. 28. The team from the Massachusetts Institute of Technology, MIT, placed third overall in the competition, judged by SpaceX engineers. 29. The second Hyperloop pod competition took place from August 25 to 27, 2017. The only judging criteria being top speed, provided it is followed by successful deceleration. WAR Hyperloop from the Technical University of Munich won the competition by reaching a top speed of 324 km per hour, 201 miles per hour, and therefore breaking the previous record of 310 km per hour for Hyperloop prototypes set by Hyperloop 1 on their own test track. 30. 31. 32. A third Hyperloop pod competition took place in July 2018. The defending champions, the WAR Hyperloop team from the Technical University of Munich, beat their own record with a top speed of 457 km per hour, 284 miles per hour during their run. 33. The fourth competition in August 2019 saw the team from the Technical University of Munich, now known as TUM Hyperloop, by Next Prototypes EV, 34 again winning the competition and beating their own record with a top speed of 463 km/h, 288 miles per hour. 27. Theory and operation. Edit. Artist's impression of a Hyperloop capsule: axial compressor on the front, passenger compartment in the middle, battery compartment at the back, and air caster skis at the bottom. A 3D sketch of the Hyperloop infrastructure. The steel tubes are rendered transparent in this image. Developments in high-speed rail have historically been impeded by the difficulties in managing friction and air resistance citation needed, both of which become substantial when vehicles approach high speeds. The vac train concept theoretically eliminates these obstacles by employing magnetically levitating trains in evacuated, airless, or partly evacuated tubes, allowing for speeds of thousands of miles per hour. However, the high cost of maglev and the difficulty of maintaining a vacuum over large distances has prevented this type of system from ever being built. The Hyperloop resembles a vac train system but operates at approximately 1 millibar, 100 pa, of pressure 35. Initial design concept edit. The Hyperloop concept operates by sending specially designed capsules or pods through a steel tube maintained at a partial vacuum. In Musk's original concept, each capsule floats on a 0.02 to 0.05 in, 0.5 to 1.3 millimeters, layer of air provided under pressure to air caster skis, similar to how pucks are levitated above an air hockey table, while still allowing faster speeds than wheels can sustain. Hyperloop 1's technology uses passive maglev for the same purpose. Linear induction motors located along the tube would accelerate and decelerate the capsule to the appropriate speed for each section of the tube route. With rolling resistance eliminated and air resistance greatly reduced, the capsules can glide for the bulk of the journey. In Musk's original Hyperloop concept, an electrically driven inlet fan and axial compressor would be placed at the nose of the capsule to actively transfer high-pressure air from the front to the rear of the vessel, resolving the problem of air pressure building in front of the vehicle, slowing it down. A fraction of the air is shunted to the skis for additional pressure, augmenting that gain passively from lift due to their shape. Hyperloop 1 system does away with the compressor. In the alpha-level concept, passenger-only pods are to be 7 feet 4 in, 2.23 m, in diameter 1 and projected to reach a top speed of 760 miles per hour 1,220 kilometers per hour to maintain aerodynamic efficiency. 1. Section 4.4, the design proposes passengers experience a maximum inertial acceleration of 0.5 g, about 2 or 3 times that of a commercial airliner on takeoff and landing. Proposed routes edit. Interstate 5. A number of routes have been proposed for Hyperloop systems that meet the approximate distance conditions for which a Hyperloop is hypothesized to provide improved transport times. Route proposals range from speculation described in company releases to business cases to signed agreements. United States. The route suggested in the 2013 Alpha-level design document was from the greater Los Angeles area to the San Francisco Bay Area. That conceptual system would begin around Sylmar, just south of the Tejon Pass, follow Interstate 5 to the north, and arrive near Hayward on the east side of San Francisco Bay. Several proposed branches were also shown in the design document, including Sacramento, Anaheim, San Diego, and Las Vegas. 1. No work has been done on the route proposed in Musk's Alpha design. One cited reason is that it would terminate on the fringes of the 2 major metropolitan areas, Los Angeles and San Francisco, resulting in significant cost savings in construction, but requiring that passengers traveling to and from downtown Los Angeles and San Francisco, and any other community beyond Sylmar and Hayward, to transfer to another transportation mode in order to reach their final destination. This would significantly lengthen the total travel time to those destinations. 36. A similar problem already affects present-day air travel, where on short routes, like LAX SFO, the flight time is only a rather small part of door-to-door travel time. Critics have argued that this would significantly reduce the proposed cost and/or time savings of Hyperloop as compared to the California high-speed rail project that will serve downtown stations in both San Francisco and Los Angeles. 37, 38, 39 passengers traveling financial center to financial center are estimated to save about 2 hours by taking the Hyperloop instead of driving the whole distance. 40. Others question the cost projections for the suggested California route. Some transportation engineers argued in 2013 that they found the Alpha-level design cost estimates unrealistically low given the scale of construction and reliance on unproven technology. The technological and economic feasibility of the idea is unproven and a subject of significant debate. 5, 6, 7, 36. In November 2017, Arrivo announced a plan for a maglev automobile transport system from Aurora, Colorado to Denver International Airport, the first leg of a system from downtown Denver. 41 Its contract describes completion of the first leg in 2021. In February 2018, Hyperloop Transportation Technologies announced a similar plan for a loop connecting Chicago and Cleveland and a loop connecting Washington and New York City. 42. In 2018, the Missouri Hyperloop Coalition was formed between Virgin Hyperloop 1, the University of Missouri, and engineering firm Black & Veatch to study a proposed route connecting St. Louis, Columbia, and Kansas City. 43-44. On December 19, 2018, Elon Musk unveiled a 2-mile, 3 kilometers, tunnel below Los Angeles. In the presentation, a Tesla Model X drove on the predefined track. According to Musk, the costs for the system are $10 million. 45. The Northeast Ohio Area-Wide Coordinating Agency, or NOCA, has partnered with Hyperloop Transportation Technologies to conduct a $1.3 million feasibility study for developing a Hyperloop corridor route from Chicago to Cleveland and Pittsburgh for America's first multi-state Hyperloop system in the Great Lakes megaregion. Hundreds of thousands of dollars already have been committed to the project. NOCA's board of directors has awarded a $550,029 contract to Transportation Economics and Management Systems Incorporated, TEMS, for the Great Lakes Hyperloop feasibility study to evaluate the feasibility of an ultra-high-speed Hyperloop passenger and freight transport system initially linking Cleveland and Chicago. 46. India. Hyperloop Transportation Technologies are in process to sign a letter of intent with the Indian government for a proposed route between Chennai and Bengaluru. If things go as planned, the distance of 345 kilometers could be covered in 30 minutes. 47. HTT also signed an agreement with Andhra Pradesh government to build India's first Hyperloop project connecting Amaravati to Vijayawada in a 6-minute ride. On February 22, 2018, Hyperloop 1 has entered into a Memorandum of Understanding, with the government of Maharashtra to build a Hyperloop transportation system between Mumbai and Pune that would cut the travel time from the current 180 minutes to just 20 minutes. 48-49. Indore-based Dinclix Groundworks DGW Hyperloop advocates a Hyperloop corridor between Mumbai and Delhi, via Indore, Kota, and Jaipur. 50. Elsewhere, many of the active Hyperloop routes being planned currently are outside of the US. Hyperloop 1 published the world's first detailed business case for a 300-mile, 500 kilometers, route between Helsinki and Stockholm, which would tunnel under the Baltic Sea to connect the two capitals in under 30 minutes. 51. Hyperloop 1 is also well underway on a feasibility study with DP World to move containers from its port of Jebel Ali in Dubai. 52. Hyperloop 1 on November 8, 2016, announced a new feasibility study with Dubai's Roads and Transport Authority for passenger and freight routes connecting Dubai with the Greater United Arab Emirates. Hyperloop 1 is also working on passenger routes in Moscow. 53-54 and a cargo Hyperloop to connect Hunchun in northeastern China to the port of Zarubino near Vladivostok and the North Korean border on Russia's Far East. 55. In May 2016, Hyperloop 1 kicked off their global challenge with a call for comprehensive proposals of Hyperloop networks around the world. 56. In September 2017, Hyperloop 1 selected 10 routes from 35 of the strongest proposals: Toronto, Montreal, Cheyenne, Denver, Pueblo, Miami, Orlando, Dallas, Laredo, Houston, Chicago, Columbus, Pittsburgh, Mexico City, Guadalajara, Edinburgh, London, Glasgow, Liverpool, Bengaluru, Chennai, and Mumbai. Chennai. 57-58. Others have put forward European routes, including a route beginning at Amsterdam or Schiphol to Frankfurt proposed by Hart. Hyperloop. 59-60-61 A Warsaw University of Technology team is evaluating potential routes from Krakow to Gdansk across Poland proposed by Hyper Poland. 62. Transport is exploring the possibility of Hyperloop routes which would connect Toronto and Montreal 63-64, Toronto to Windsor 65 and Calgary to Edmonton 66. Toronto and Montreal, the largest cities in Canada, are currently connected by Ontario Highway 401, the busiest highway in North America 67. In March 2019, Transport Canada commissioned the study of the Hyperloop, so it can be better informed on the technical, operational, economic, safety, and regulatory aspects of the Hyperloop and understand its construction requirements and commercial feasibility. 68. Hyperloop Transportation Technologies, HTT, reportedly signed an agreement with the government of Slovakia in March 2016 to perform impact studies, with potential links between Bratislava, Vienna, and Budapest, but there have been no developments on that since 69. In January 2017, HTT signed an agreement to explore the route Bratislava-Brno-Prague in Central Europe. 70. In 2017, SINTEF, the largest independent research organization in Scandinavia, announced they are considering building a test lab for Hyperloop in Norway. 71. An agreement was signed in June 2017 to co-develop a Hyperloop line between Seoul and Busan in South Korea. 72-73. Open Source Design Evolution Edit. In September 2013, ANSYS Corporation ran computational fluid dynamics simulations to model the aerodynamics of the capsule and shear stress forces that the capsule would be subjected to. The simulation showed that the capsule design would need to be significantly reshaped to avoid creating supersonic airflow, and that the gap between the tube wall and capsule would need to be larger. ANSYS employee Sundeep Savani said the simulation showed that Hyperloop has challenges but that he is convinced it is feasible. 74-75. In October 2013, the development team of the OpenMDAO software framework released an unfinished, conceptual open-source model of parts of the Hyperloop's propulsion system. The team asserted that the model demonstrated the concept's feasibility, although the tube would need to be 13 feet, 4 m, in diameter, 76, significantly larger than originally projected. However, the team's model is not a true working model of the propulsion system, as it did not account for a wide range of technological factors required to physically construct a Hyperloop based on Musk's concept, and in particular had no significant estimations of component weight. 77. In November 2013, MathWorks analyzed the proposal's suggested route and concluded that the route was mainly feasible. The analysis focused on the acceleration experienced by passengers and the necessary deviations from public roads in order to keep the accelerations reasonable. It did highlight that maintaining a trajectory along I-580 east of San Francisco at the planned speeds was not possible without significant deviation into heavily populated areas. 78. In January 2015, a paper based on the NASA OpenMDAO open source model reiterated the need for a larger diameter tube and a reduced cruise speed closer to Mach 0.85. It recommended removing onboard heat exchangers based on thermal models of the interactions between the compressor cycle, tube, and ambient environment. The compression cycle would only contribute 5% of the heat added to the tube, with 95% of the heat attributed to radiation and convection into the tube. The weight and volume penalty of onboard heat exchangers would not be worth the minor benefit, and regardless the steady-state temperature in the tube would only reach 30 to 40 degrees Fahrenheit, 17 to 22 degrees Celsius, above ambient temperature. 79. According to Musk, various aspects of the Hyperloop have technology applications to other Musk interests, including surface transportation on Mars and electric jet propulsion. 80-81. Researchers associated with MIT's Department of Aeronautics and Astronautics published research in June 2017 that verified the challenge of aerodynamic design near the Kantowitz limit that had been theorized in the original SpaceX Alpha design concept released in 2013. 82. In 2017, Dr. Richard Geddes and others formed the Hyperloop Advanced Research Partnership to act as a clearinghouse of Hyperloop public domain reports and data. 83. In February 2020, HART Hyperloop, Hyper Poland, Transpod and Zeleros formed a consortium to drive standardization efforts, as part of a joint technical committee, JTC20, set up by European standards bodies CEN and CENELEC to develop common standards aimed at ensuring the safety and interoperability of infrastructure, rolling stock, signaling and other systems. 84. Mars edit. According to Musk, Hyperloop would be useful on Mars as no tubes would be needed because Mars' atmosphere is about 1% the density of the Earth's at sea level. 85. 11. 86. 87. For the Hyperloop concept to work on Earth, low-pressure tubes are required to reduce air resistance. However, if they were to be built on Mars, the lower air resistance would allow a Hyperloop to be created with no tube, only a track. 88. Hyperloop companies edit. Virgin Hyperloop 1 edit. Main article, Virgin Hyperloop 1. Virgin Hyperloop 1, formerly Hyperloop 1, and before that, Hyperloop Technologies, 8990 was incorporated in 2014 and has built a team of 280 plus, when, including engineers, technicians, welders, and machinists. It has raised more than $160 million in capital from investors including DP World, Sherpa Capital, Formation 8, 137 Ventures, Caspian Venture Capital, Fast Digital, GE Ventures, and SNCF. Citation needed. Hyperloop 1 was founded by Shervin Pishavar and Brogan Bambrogan. 91. Bambrogan left the company in July 2016. 92. Along with 3 of the other founding members of Arrivo. 93. Hyperloop 1 then selected Josh Jiggle, a former SpaceX engineer, to be a co-founder. 94. Hyperloop 1 has a 75,000 square foot innovation campus in downtown LA and a 100,000 square foot machine and tooling shop in North Las Vegas. By 2017, it had completed a 500m development loop, DevLoop, in North Las Vegas, Nevada. 95. On May 11, 2016, Hyperloop 1 conducted the first live trial of Hyperloop technology, demonstrating that its custom linear electric motor could propel a sled from 0 to 110 miles an hour in just over 1 second. 96. The acceleration exerted approximately 2.5 g on the sled. The sled was stopped at the end of the test by hitting a pile of sand at the end of the track, because the test was not intended to test braking components. Citation needed. In July 2016, Hyperloop 1 released a preliminary study that suggested a Hyperloop connection between Helsinki and Stockholm would be feasible, reducing the travel time between the cities to half an hour. The construction costs were estimated by Hyperloop 1 to be around 19 billion euros, $21 billion at 2016 exchange rates. 97. In August 2016, Hyperloop 1 announced a deal with the world's third-largest ports operator, DP World, to develop a cargo offloader system at DP World's flagship port of Jebel Ali in Dubai. 98. Hyperloop 1 also broke ground on DevLoop, its full-scale Hyperloop test track. In November 2016, Hyperloop 1 disclosed that it has established a high-level working group relationship with the governments of Finland and the Netherlands to study the viability of building Hyperloop proof of operations centers in those countries. Hyperloop 1 also has a feasibility study underway with Dubai's Roads and Transport Authority for passenger systems in the UAE. 99 other feasibility studies are underway in Russia, Los Angeles, and the Netherlands. In May 12, 2017, Hyperloop 1 performed its first full-scale Hyperloop test, becoming the first company in the world to test a full-scale Hyperloop 100. The system-wide test integrated Hyperloop components including vacuum, propulsion, levitation, sled, control systems, tube, and structures. On July 12, 2017, the company revealed images of its first-generation pod prototype, which will be used at the DevLoop test site in Nevada to test aerodynamics. 101. On October 12, 2017, the company received a significant investment from the Virgin Group founder Richard Branson, leading to a rebrand of the name 102. In February 2018, Richard Branson of Virgin Hyperloop One announced that he had a preliminary agreement with the Maharashtra state government of India to build the Mumbai-Pune Hyperloop 103. In 2019, a partnership was formed between Virgin Hyperloop One, the University of Missouri, and engineering firm Black & Veatch to investigate a Missouri Hyperloop 4344. In March 2019, Missouri Governor Mike Parson announced the creation of a blue ribbon panel to examine the specifics of funding and construction of the Missouri Hyperloop 104. The route would connect Missouri's largest sites including St. Louis, Kansas City, and Columbia 105. This comes after a 2018 feasibility study found the route viable, the first such study in the United States. 106. In June 2019, a partnership with the Sam Fox School of Washington University of St. Louis was announced to further investigate different proposals for the Missouri Hyperloop 107. In July 2019, the government of Maharashtra and Hyperloop One set a target to create the first Hyperloop system in the world between Pune and Mumbai. Citation needed. Hyperloop Transportation Technologies edit. Main article, Hyperloop Transportation Technologies. Hyperloop Transportation Technologies, HTT, is the first Hyperloop company created, founded in 2013, with a current workforce of more than 800 engineers and professionals located around the world. 108. Some collaborate part-time, others are full-time employees and contributors. Some members are full-time paid employees, others work in exchange for salary and stock options. 109. After Musk's Hyperloop concept proposal in 2012, Jumpstarter, Inc. founder Dirk Eilborn placed a call to action on his Jumpstarter platform. 110. Jumpstarter started pooling resources and amassed 420 people to the team. 110. HTT announced in May 2015 that a deal had been finalized with landowners to build a 5-mile, 8 kilometers, test track along a stretch of road near Interstate 5 between Los Angeles and San Francisco. 111. In December 2016, Hyperloop Transportation Technologies and the government of Abu Dhabi announced plans to conduct a feasibility study on a Hyperloop link between the UAE capital and Al Ain, reducing travel time between Abu Dhabi and Al Ain to just under 10 minutes. 112. In September 2017, HTT announced and signed an agreement with the Andhra Pradesh state government of India to build a track from Amaravati to Vijayawada in a public-private partnership, and suggested that the more than 1-hour trip could be reduced to 5 minutes through the project. 114. For yet undisclosed reason, neither the test track that HTT announced in May 2015 nor any other test track has been built in the last 3 years. In June 2018, Ukraine's infrastructure ministry reached an agreement with Hyperloop Transportation Technologies to develop its high-speed vacuum transport technology in Ukraine. 115. According to Minister Volodymyr Omelyan, a joint research and development center will be created in Kiev or Dnipro, which will not only work on Hyperloop but new materials and components for modern transportation systems. 115. Later in 2018, the company signed an agreement with the Guizhou province of China to build a Hyperloop 116. In its China deal, HTT will provide technology, engineering expertise, and essential equipment in the venture, while Tongren will take charge of relevant certifications, regulatory framework, and construction of the system, the press release said. The venture will be a public-private partnership in which 50% of the funds will come directly from Tongren, it added. 116. In May 2019, the company and TÜV SÜD presented the EU with generic guidelines for Hyperloop design, operation, and certification. 117. In June 2019, Hyperloop Transportation Technologies met with officials from the United States Department of Transportation, USDOT, at Hyperloop's research facilities in Toulouse, France. 118. Simultaneously, other members of Hyperloop TT met with the USDOT at the agency's offices in Washington, D.C. presenting a technical overview of Hyperloop technology and the certification guideline completed by TÜV SÜD. 118. Hyperloop TT is now beginning the process of integrating their full-scale passenger capsule for human trials in 2020-118. Transpod edit. Main article, Transpod. Transpod Incorporated is a Canadian company designing and manufacturing ultra-high-speed tube transportation technology and vehicles. 119 In November 2016, Transpod raised a $15 million seed round from Angelo Investments, an Italian high-tech holding group, specializing in advanced technologies for the railway, space, and aviation industries. 120. In September 2017, Transpod released a scientific peer-reviewed publication in the journal Prostia Engineering. 121 The paper was premiered at the EASD Uridan 2017 conference. 122 and presents the physics of the Transpod system. 123. Transpod vehicles are being designed to travel at over 1,000 km per hour between cities using fully electric propulsion and zero need for fossil fuels. 123 The Transpod tube system is distinct from the Hyperloop concept proposed by Elon Musk's Hyperloop Alpha white paper. The Transpod system uses moving electromagnetic fields to propel the vehicles with stable levitation off the bottom surface, rather than compressed air. 123 Transpod is stated to contain further developments beyond Hyperloop. 124-125 To achieve fossil fuel-free propulsion, Transpod pods take advantage of electrically driven linear induction motor technology, with active real-time control. 123 and Sense Space Systems. 126 The cargo transport Transpod pods will be able to carry payloads of 10 to 15 tons and have compatibility with wooden pallets, as well as various unit load devices such as LD3 containers, and AAA containers. 127. At the InnoTrans Rail Show 2016 in Berlin, Transpod premiered their vehicle concept, alongside implementation of Kylix technology and artificial skylight to emulate natural sunlight within the passenger pods. 128-129. Transpod has partnered with investor Angelo Investments member companies Mermec, Citail, and Black Shape Aircraft. With international staff of over 1,000 employees, 650 of whom are engineers, they will collaborate with the development and testing of the Transpod tube system. 130 131 120 It has since expanded from its Toronto, Canada headquarters at Mars Discovery District. 132 133 to open offices in Toulouse, France, and Bari, Italy. 134 135 Transpod is additionally partnered with university researchers, engineering firm IKOS. 136 Rec Architecture and Liebherr Aerospace. 137 138 139 Transpod is developing routes worldwide and in Canada such as Toronto Montreal. 140 64 141 Toronto Windsor 65 and Calgary Edmonton 66 Transpod is preparing to build a test track for the pod vehicles in Canada. 142 This track will be extendable as part of a full route pending a combination of private and public funding to construct the Line 66. In July 2017, Transpod released an initial cost study 143 which outlines the viability of building a Hyperloop line in southwestern Ontario between the cities of Windsor and Toronto. 144 The study indicates a Transpod tube system would cost half the projected cost of a high-speed rail line along the same route, while operating at more than 4 times the top speed of high-speed rail. 143 Transpod has announced plans for a test track to be constructed in the town of Dreux near Limoges. 145 in collaboration with the French Department of Haute-Vienne. The proposed test track would exceed 3 kilometers in length, and operate as a half-scale system 2 m in diameter. 146 147 148 In February 2018 Vincent Leone, Vice President of Limoges Metropole and a Deputy Mayor of Limoges. 149 has announced agreements for the Hyperloop Limoges organization have been signed to promote and accelerate the technology. 146 DGW Hyperloop edit. Established in 2015, DGW Hyperloop is a subsidiary of Dinclix Groundworks, an engineering company based in Indore, India. 150 Hyperloop's initial proposals include a Hyperloop-based corridor between Delhi and Mumbai called the Delhi-Mumbai Hyperloop Corridor, DMHC. 151-152 The company has partnered with many government agencies, private companies, and institutions for its research on Hyperloop. 153 DGW Hyperloop is the only Indian company working on implementing the Hyperloop system across the nation. 154 155 156 Arrivo edit. Arrivo was a technology architecture and engineering company founded in Los Angeles in 2016. 157 In November 2017, it disclosed a plan to build a 200 miles per hour 320 kilometers per hour link for automobiles to Denver International Airport using maglev train technology by 2021. 41 On December 14, 2018, technology news site The Verge reported Arrivo was shutting down due to being unable to secure a series of funding. 158 Hart Global Mobility edit. Hart Global Mobility 159 was founded in 2016 in Delft, emerging from the two Delft Hyperloop team who won at the SpaceX Pod Competition 26. The Dutch team is setting up a full-scale testing center for Hyperloop technology in Delft. Hart has received over €600,000 in funding for the initial rounds of testing, with plans to raise more to build a high-speed test line by 2019. 160 At the unveiling of the test track, Dutch Minister of Infrastructure and Environment Schultz van Heegen said a Hyperloop system could help cement the Netherlands' position as a gateway to Europe by transporting freight arriving at Rotterdam's sprawling port. 161 In October 9, 2017, a report was released with information from Hart Global Mobility and Hyperloop One. The report has been sent to the Dutch House of Representatives and judges the added value of a Hyperloop test track facility. The report recommends building a test track of 5 kilometers in Flevoland. 162 Hyperchariot edit. Hyperchariot is a startup company based in Santa Monica, United States, that promoted itself from May to July 2017. The company has an ambitious plan. 163 On July 27, 2017, it announced a partnership with AML Superconductivity and Magnetics for the development of the vehicle and related propulsion system. 164 Zeleros edit. Zeleros 165-166 was founded in Valencia, Spain, in November 2016 by Daniel Orient, CTO, David Pistonai, CEO, and Juan Vicen, CMO, former leaders of the Hyperloop UPV team from Universitat Politècnica de Valencia. The team was awarded Top Design Concept and Propulsion/Compression Subsystem Technical Excellence at SpaceX's Hyperloop Design Weekend, the first phase of the Hyperloop Pod competition conducted at Texas A&M University on January 29 to 30, 2016. 167 After building Spain's first Hyperloop prototype with the support of Purdue University. 168 And building a 12-meter research test track in Spain. 169 At the university, the company was awarded in November 2017 the International Evries Foundation Prize. 170 Zeleros has the support of the Silicon Valley Accelerator Plug and Play Tech Center. Citation needed. Its partner Alberto Gutierrez, partner of Plug and Play Spain and founder of Aqua Service, and the Spanish venture capital fund Angels Capital. Citation needed. Owned by the Spanish businessman Juan Roig, owner of Mercadona. By June 2018, the corporation signed an agreement with the rest of the Hyperloop European companies, Hyper Poland and Hart, and the Canadian Transpod to collaborate with the European Union and other international institutions for the implementation of a definition of the standards to ensure the interoperability and the security of a Hyperloop. In August 2018, Zeleros held a meeting with Pedro Duque, the Ministry of Science. Citation needed to push for his support of the European initiative. By September 2018, the corporation announced the construction of a 2 km test track to perform dynamic tests of the system. The test track will be allocated in Sagunto in 2019 with the support of the Sagunto Council and the Generalitat Valenciana citation needed in November 2018. Zeleros received the International Award in the World Transport Congress in Mascate, Oman 171. Currently, the corporation is formed by a team of 20 engineers and doctors specialized in different fields, developing and testing the systems and subsystems of the Hyperloop integrators. Hyperpoland edit. Hyperpoland 62 is a Polish company founded in 2017 by engineers who graduated from the Warsaw University of Technology. In the summer of 2017, acting as the Hyperpoland University team, they built a Hyperloop model which took part in the SpaceX Pod Competition 2 in California. In March 2018, the company was recognized as one of the best startups in the mobility sector in Europe 172. Hyperloop Pod Competition edit. Main article, Hyperloop Pod Competition. Hyperloop Pod Competition. A number of student and non-student teams were participating in a Hyperloop Pod competition in 2015-16, and at least 22 of them built hardware to compete on a sponsored Hyperloop test track in mid-2016 173. In June 2015, SpaceX announced that they would sponsor a Hyperloop pod design competition, and would build a 1-mile-long, 1.6 kilometers, subscale test track near SpaceX's headquarters in Hawthorne, California for the competitive event in 2016 175. SpaceX stated in their announcement, neither SpaceX nor Elon Musk is affiliated with any Hyperloop companies. While we are not developing a commercial Hyperloop ourselves, we are interested in helping to accelerate development of a functional Hyperloop prototype. 176. More than 700 teams had submitted preliminary applications by July 177 and detailed competition rules were released in August 178. Intent to compete submissions were due in September 2015 with more detailed tube and technical specification released by SpaceX in October. A preliminary design briefing was held in November 2015, where more than 120 student engineering teams were selected to submit final design packages due by January 13, 2016 179. A design weekend was held at Texas A&M University January 29 to 30, 2016, for all invited entrants. 180 engineers from the Massachusetts Institute of Technology were named the winners of the competition. While the University of Washington team won the Safety Subsystem Award, Delft University won the Pod Innovation Award 181 as well as the second place, followed by the University of Wisconsin, Madison, Virginia Tech, and the University of California, Irvine 173. 182 in the design category. The winner team was Hyperloop UPV from Universitat Politècnica de Valencia, Spain 183. On January 29, 2017, Delft Hyperloop, Delft University of Technology, won the prize for the best overall design at the final stage of the SpaceX Hyperloop competition 184, while WAR Hyperloop of the Technical University of Munich won the prize for fastest pod. 27 The Massachusetts Institute of Technology placed third 185. The second Hyperloop pod competition took place from August 25 to 27, 2017. The only judging criteria being top speed provided it is followed by successful deceleration. WAR Hyperloop from the Technical University of Munich won the competition by reaching a top speed of 324 km/h, 201 miles per hour, 30-31-32. A third Hyperloop pod competition took place in July 2018. The defending champions, the WAR Hyperloop team from the Technical University of Munich, beat their own record with a top speed of 457 km per hour 284 miles per hour during their Run 33. The fourth competition in August 2019 saw the team from the Technical University of Munich, now known as TUM Hyperloop, by Next Prototypes EV, 34 again winning the competition and beating their own record with a top speed of 463 km/h, 288 miles per hour. 27. Criticism and human factor considerations. Edit. Some critics of Hyperloop focus on the experience possibly unpleasant and frightening of riding in a narrow, sealed, windowless capsule inside a sealed steel tunnel, that is subjected to significant acceleration forces, high noise levels due to air being compressed and ducted around the capsule at near sonic speeds, and the vibration and jostling 186. Even if the tube is initially smooth, ground may shift with seismic activity. At high speeds, even minor deviations from a straight path may add considerable buffeting. 187. This is in addition to practical and logistical questions regarding how to best deal with safety issues such as equipment malfunction, accidents, and emergency evacuations. Other maglev trains are already in use, which avoid much of the added costs of Hyperloop. The SC Maglev 188 in Japan has demonstrated 603 km per hour 375 miles per hour without a vacuum tube, by using an extremely aerodynamic train design. It also avoids the cost and time required to pressurize and depressurize the exit and entry points of a Hyperloop tube. There is also the criticism of design technicalities in the tube system. John Hansman, professor of aeronautics and astronautics at MIT, has stated problems, such as how a slight misalignment in the tube would be compensated for and the potential interplay between the air cushion and the low-pressure air. He has also questioned what would happen if the power were to go out when the pod was miles away from a city. UC Berkeley physics professor Richard Muller has also expressed concern regarding the Hyperloop's novelty and the vulnerability of its tubes, which would be a tempting target for terrorists, and that the system could be disrupted by everyday dirt and grime. 189. Political and economic considerations. Edit. The Alpha proposal projected that cost savings compared with conventional rail would come from a combination of several factors. The small profile and elevated nature of the Alpha route would enable Hyperloop to be constructed primarily in the median of Interstate 5. However, whether this would be truly feasible is a matter of debate. The low profile would reduce tunnel boring requirements, and the light weight of the capsules is projected to reduce construction costs over conventional passenger rail. It was asserted that there would be less right-of-way opposition and environmental impact as well due to its small, sealed, elevated profile versus that of a rail easement one. However, other commentators contend that a smaller footprint does not guarantee less opposition. 36. In criticizing this assumption, mass transportation. Writer Alan Levy said, in reality, an all-elevated system, which is what Musk proposes with the Hyperloop, is a bug rather than a feature. Central Valley land is cheap, pylons are expensive, as can be readily seen by the costs of elevated highways and trains all over the world. 191 Michael Anderson, a professor of agricultural and resource economics at UC Berkeley, predicted that costs would amount to around $100 billion. 6. The Hyperloop white paper suggests that $20 of each one-way passenger ticket between Los Angeles and San Francisco would be sufficient to cover initial capital costs, based on amortizing the cost of Hyperloop over 20 years with ridership projections of 7.4 million per year in each direction, and does not include operating costs, although the proposal asserts that electric costs would be covered by solar panels. No total ticket price was suggested in the Alpha design. 1. The projected ticket price has been questioned by Dan Sperling, director of the Institute of Transportation Studies at UC Davis, who stated that there's no way the economics on that would ever work out. 6. The early cost estimates of the Hyperloop are a subject of debate. A number of economists and transportation experts have expressed the belief that the $6 billion price tag dramatically understates the cost of designing, developing, constructing, and testing an all-new form of transportation. 5. 636 191 The economists said that the estimates are unlikely to be immune to the hypertrophication of cost that every other grand infrastructure project seems doomed to suffer. 192. political impediments to the construction of such a project in California will be very large. There is a great deal of political and reputation capital invested in the existing megaproject of California High-Speed Rail 192. Replacing that with a different design would not be straightforward given California's political economy. Texas has been suggested as an alternate for its more amenable political and economic environment. 192. Building a successful Hyperloop subscale demonstration project could reduce the political impediments and improve cost estimates. Musk has suggested that he may be personally involved in building a demonstration prototype of the Hyperloop concept, including funding the development effort. 192. The solar panels Musk plans to install along the length of the Hyperloop system have been criticized by engineering professor Roger Goodall of Loughborough University, as not being feasible enough to return enough energy to power the Hyperloop system, arguing that the air pumps and propulsion would require much more power than the solar panels could generate. 189. Related projects edit. Historical edit. The concept of transportation of passengers in pneumatic tubes is not new. The first patent to transport goods in tubes was taken out in 1799 by the British mechanical engineer and inventor George Medhurst. In 1812, Medhurst wrote a book detailing his idea of transporting passengers and goods through airtight tubes using air propulsion. 193. In the early 1800s, there were other similar systems proposed or experimented with and were generally known as an atmospheric railway, although this term is also used for systems where the propulsion is provided by a separate pneumatic tube to the train tunnel itself. One of the earliest was the Dalkey Atmospheric Railway, which operated near Dublin between 1844 and 1854. The Crystal Palace Pneumatic Railway operated in London around 1864 and used large fans, some 22 feet 6.7 meters in diameter, that were powered by a steam engine. The tunnels are now lost, but the line operated successfully for over a year. Operated from 1870 to 1873, the Beach Pneumatic Transit was a one-block-long prototype of an underground tube transport public transit system in New York City. The system worked at near atmospheric pressure, and the passenger car moved by means of higher pressure air applied to the back of the car while somewhat lower pressure was maintained on the front of the car. 194. In the 1910s, vacuum trains were first described by American rocket pioneer Robert Goddard. 192. While the Hyperloop has significant innovations over early proposals for reduced pressure or vacuum tube transportation apparatus, the work of Goddard appears to have the greatest overlap with the Hyperloop. 4. In 1981, Princeton physicist Gerard K. O'Neill wrote about transcontinental trains using magnetic propulsion in his book 2081, A Hopeful View of the Human Future. While a work of fiction, this book was an attempt to predict future technologies in everyday life. In his prediction, he envisioned these trains which used magnetic levitation running in tunnels which had much of the air evacuated to increase speed and reduce friction. He also demonstrated a scale prototype device that accelerated a mass using magnetic propulsion to high speeds. It was called a mass driver and was a central theme in his nonfiction book on space colonization, The High Frontier. Swiss Metro was a proposal to run a maglev train in a low-pressure environment. Concessions were granted to Swiss Metro in the early 2000s to connect the Swiss cities of St. Gallen, Zurich, Basel, and Geneva. Studies of commercial feasibility reached differing conclusions and the VAC train was never built. 195. China was reported to be building a vacuum-based 600 miles per hour 1000 kilometers per hour maglev train in August 2010 according to a laboratory at Jiaotong University. It was expected to cost CNY 20 million, $2.95 million at the August 2010 exchange rate, more per kilometer than regular high-speed rail. 196. As of May 2017, it has not been built. Current edit. The ET3 Global Alliance, ET3, was founded by Darrell Oster in 1997 with the goal of establishing a global transportation system using passenger capsules in frictionless maglev full vacuum tubes. Oster and his team met with Elon Musk on September 18, 2013, to discuss the technology 197 resulting in Musk promising an investment in a 3-mile, 5 kilometers, prototype of ET3's proposed design. 198 needs update.
Well, hope you like my videos. Hope you like it. Well, maybe that's it.